Hello and welcome to Algebra 2 lesson 57. I hope you're taking notes, nice and awake and ready to go. Sorry I couldn't be there today for class, but I'm sure you guys will get this. Today's essential question, the question I want you to think about, the theme that runs through this lesson is how do our actions, or how does one action affect everything else? And we'll see that in our lesson today. We're going to turn a knob, if I may, on one quantity and see how it affects the other quantities for ideal gas laws. So let's get right into it. The big equation that you need to know is P1 V1 over T1 equals P2 V2 over T2. Go ahead and write that down on your notes. That is the big equation for the day. What do these letters stand for? Well, we are talking about ideal gases. So you're thinking like air, you're thinking oxygen, argon, neon, things that are in light bulbs, you name it, we've got it. It's a gas. And what happens with a gas? Well, it has pressure. So P stands for pressure. V stands for volume, and T stands for temperature. Once you get to chemistry, we'll actually turn up the difficulty on this and it'll get a little bit more complicated. But for now, in Algebra 2, this is what we're going to work with. So you have an initial pressure, volume, and temperature, and then one of those is going to change. They're either going to increase the pressure, increase the volume, decrease the temperature. Something is going to change from the initial to the final, and you're going to have to calculate some new quantities. You're going to see how changing one thing here affects everything over there. Now, spiritually, this is a great question because oftentimes in our lives, something small that we do over here in our life will affect everything else we do. For example, if you are a prayer warrior, and I pray that you are, and that is something that you do faithfully all the time. I remember one of my Sunday school teachers back in 4th grade, his name was Tito. Everyone had him. He was like this wonderful old man, and he was a prayer warrior for the church. We used to have prayer meetings every Thursday. He would show up. We also knew that Tito would take every single prayer request from the entire church and pray for it faithfully. And it was all behind the scenes. We didn't find this out till years later that he was doing this. But I know that that prayer, even though it was just a small thing for him, right? Well, it was a big thing for him, but it was a small thing, right? Just going into his prayer closet, spending time with the Lord over our church has now helped the church grow because of that, okay? Similarly, if you let little things grow in your life like sin, how is that going to affect everything else? Well, pretty significantly. So I want you to think about that as we talk about these problems. So here's a sample problem. We have 4 liters of an ideal gas at a temperature of 800 Kelvin and pressure 100 newtons per meter squared. Now, sometimes it'll tell you this is the volume, this is the pressure, this is the temperature. Other times you're going to have to figure that out. So what I want you to do is look at the units, okay? Liters, obviously you can buy a 2-liter soda, that's volume, okay? Temperatures, you're either going to have Fahrenheit, Celsius, or Kelvin. And then pressure is all over the place. So usually you can figure out the volume units, you can figure out the temperature units, and then the leftover one is the pressure unit. What they've told us is that we have 4 liters of an ideal gas at a temperature of 800 Kelvin and pressure of 100 newtons per meter squared. These are all your initial values, or V1, T1, and P1. Now, let's see what the actual problem is asking for. It says, if the volume were increased to 10, so now our volume is 10 liters, and the temperature is reduced to 600 Kelvin. So now we know our temperature is 600 Kelvin. What would the pressure be? So we've changed a couple of these knobs, and now we want to see how that's going to change our pressure. So what I want you guys to do when you're solving these problems is first to plug into the equation. So what is our equation? P1 V1 over T1 equals P2 V2 over T2. That's an ugly 2, I'm sorry. Now we're going to plug in the values we know. V1 is 4, so I'm going to plug that in parentheses. T1 is 800, and P1 is 100. Okay, you know that because they say you started with those amounts, and then this happened. So then is your big keyword between the 1s and the 2s. Then something happened. They changed the volume, they cooled it down, they put it in the refrigerator, and so P2 is unknown because that's what we're solving for. So make sure you leave that as a variable. Don't try and plug in numbers. That's what you want. Okay, V2 is 10 and T2 is 600. Now, how do we solve this from here? Well, simply get everything that's not P2 away from it. So I'm going to multiply by 600 on the top and bottom, so those cancel. And I'm going to divide by 10, so those cancel. And so my answer, and you should get a numerical answer, so multiply this one out. 100 times 4 times 600 over 800 times 10. Now, if you find yourself without a calculator, usually the hundreds you can cancel. 4 and 8 you can cancel. 600 and 10 you can cancel. Now it looks like I have 60 divided by 2, which is 30. Not bad. If you have a calculator, just plug it in. Don't chance like messing up the small multiplication. Okay? Now, 30 is the correct answer, but I must have units. So I'm going to go back to what my pressure units were given in the problem. I knew that it was newtons per meter squared, so my answer should be in newtons per meter squared. Circle your answer, and you're set. Now, one word of caution, and then I'll let you get started on your homework. When we look at these problems, sometimes instead of giving you 2 volumes, they'll say the volume remained constant. What that means is that the volume for the first time is the same as the volume for the second time. So, if that's true, you can just remove volume from your equation. And then it's just P1 over T1 equals P2 over T2. If they keep the pressure the same, you can remove pressure from your equation. So that, my friends, is problem set 57. Again, think about our question. How do our actions affect everything else around us? I think it'll be quite illuminating as you're doing these problems. See you guys.